My name is Byron. Welcome, everybody. Thanks for having me. I work at Facebook on a team called Product Infrastructure, and we're responsible for finding and attempting to solve broad problems in product development and software development. The results of that is usually libraries, tools, patterns that we end up using in production at Facebook, but ideally we also open source. And our team is responsible for a lot of the open source projects that you may have heard about from Facebook that have come out over the last couple of years. And I've gotten to work on a bunch of them, which has been a lot of fun, which includes React, Immutable.js, and Graphql, which I'm going to tell you guys about today. We recently published Graphql, a specification for Graphql, about 4 months ago, and we announced it at the React Europe conference. Was anybody here at that conference by chance? No? All right, cool. All fresh faces. I'm recycling a lot of that talk, so I just was going to have a warning that if you've seen it before, still stick around because I've added a lot to it, but the initial bit here will look a little familiar. And we're going to dive in. We're going to get deep into what GraphQl is, how it works, why it's useful. But I think what is actually more interesting is where it came from, why we went down this path in the first place. And so what I want to start with is the story of where GraphQl started. And our story starts over 4 years ago when Facebook was trying to get serious about mobile development. In 2011 and the years before, Facebook completely revolved around the web. And the web is part of our DNA as a company. We started as a website, and it still really is to a large degree. It's something that we deeply understand, we have a lot of expertise in. And at that point, certainly, and today, even still, we're very much architected to support the web. And so this is a high-level overview of the Facebook technology stack at a time. We have a web server. We get requests from a browser. We return HTML. And that's pretty much it. So you have this question, like mobile apps. What do you do about mobile apps? And we had mobile apps. We had iOS and Android apps. And the teams working on these were really small. And they could only do a very small portion of what the website could do. The thought being that you use mobile occasionally when you're away from your desktop computer. Of course, that's like not how people use mobile. And if we were going to be serious about mobile, we needed to catch up to the capabilities that we had on the desktop web. And in order to do that, we really needed to take advantage of as much existing work that we had done as possible. So this is what we did. We created HTML5 apps, which were really native apps that wrapped a web browser that served our mobile website, a customized version of it. This allowed us to reuse all the stuff that we had built. It let us go to the engineers and say, hey, you guys get web. Now you can build for mobile too. You don't have to think about building on all these different platforms. It was great. So for our primary goal of going from mobile being an afterthought to mobile being the first thing we think about when developing on Facebook, this was a huge success. We were able to develop a considerable surface area of Facebook for mobile in well under a year. And in doing so, we shifted the company's focus and attention to mobile for the years to come. There were some problems with this. As our apps started to get a little more sophisticated, we started having larger images, we get retina displays where there's more information coming back and forth, videos, rich animations, interactive gestures. The mobile web browser technology, it couldn't keep up. At best, we had just crappy frame rate. But more often than not, we would just consume all the memory on the device and crash. And we had made a bet. We thought mobile web was the future. When Apple first announced the iPhone and iOS, the web browser was the primary tool. Of course, the first question asked when Steve launched the iPhone was, how can we build stuff for this? He was like, it's easy. You just make a website. And so that's what we were doing. But it became more clear as incremental versions of iOS came out that the amount of attention that they were putting on their web browser was not nearly as much as the attention they were putting on new features, new SDKs, performance for their native apps. And this is even worse on Android, where there's device spread, and the initial browser stack on Android was just not even as good as mobile Safari. So in the beginning of 2012, we started an effort to develop a truly native version of Newsfeed. We could leave the rest of the app in this HTML5 style, but Newsfeed, it's the most important part of Facebook. It's the thing that you see first when you open the app, and that had to be excellent. So this sounds obvious. Duh, okay, yeah, just make a mobile app. But this was far from a modest undertaking for us. And it was really the first time that the client side of our stack was doing a lot of business logic. Instead of using URLs and HTML, now we're really thinking of everything as models and views. And it required us to rethink how we build stuff. So we shift from this to this. Applications that just deliver pure data. Turned out that a lot of our backend services didn't think about things that way. They thought about it in terms of just HTML strings. So this was a lot of work. And in order to render native apps, native newsfeed, with the data that they needed, we needed to figure out how to request, parse, deliver that information as efficiently as we could. So we tried a couple things. This was all new to us. We have a public RESTful API, so we were going to dig into that, improve it, use that for our internal newsfeed. And as we got started with this, it worked out okay in the beginning, but we found a lot of kind of itchy spots, things that didn't feel so good. We found ourselves writing a lot of custom parsing logic. It turned out that the model objects that we were getting from the server just didn't exactly align to the way that we wanted to treat the model objects as we were operating on them in the client environment in iOS. So we were writing custom logic to parse that. We were also writing a lot of custom code to deal with the network stack itself, just all of the basic boilerplate of getting the network stack up and running, authentication, all that stuff. But in addition to that, coordinating different parallel requests, secondary round trips to get supplementary information. And oftentimes this ended up with multiple back and forths. And on a desktop machine, that might be acceptable. On mobile, that's really bad, where in some environments, the average round trip time is 12 seconds. That's not worse, that's mean. And the average request drop is 20%. So 1 out of 5 chance it doesn't come back at all. And if it does, it takes 12 seconds. So if you say, well, instead of 1 request, we're going to have to send 3, now you're talking 36, 40 seconds. And instead of 1 out of 5 chance, I don't know, do the math, but it's a lot worse. So we really needed to focus on doing a single round trip per set of information that we required. Typically, you fix this by using query parameters. You can alter the response, or you can just create custom resources. So you have a custom resource for the iOS newsfeed, and you have that return just everything that you need. But that starts to brush against the principles of good RESTful development, where you keep your resources isolated. And you know, as I talk through these problems, you might be thinking to yourself, well, hey, you're just not using REST correctly. There are tools that you can use to build this. And, oh yeah, I'm going through some of these things. There are tools to do this. But we still felt like we had this tight coupling, where the server knew too much about what our app was doing with low cohesion. If you needed to make changes, you had to simultaneously operate both on the server and in the iOS codebase. And there just weren't that many engineers that were very comfortable in both environments to be able to move quickly and develop products. And so, yeah, there are technologies to solve this that you can build on top of REST. Someone posted this in a Hacker News thread. I think this is great. There's a veritable soup of these technologies, and we evaluated a lot of them, but we were just still not satisfied. And I'm also not claiming that we're the first to see these kinds of problems, and certainly not the first to attempt to solve them. But nonetheless, we jumped in. So despite the frustration that we had with REST, we realized we were actually just not thinking about it the right way. We needed something that was going to be easier to understand, that offered a little bit more structure. And the main thing here was that we don't want to think about our data as resource URLs. We don't want to think about our data as join queries or secondary indices. These are principles that are important for the efficient storage and retrieval of data, but as a client developer, I couldn't care less. What I want to think about is the network of data, the graph, the relationships between all of the pieces of information that I am capable of eventually accessing. Whether that ends up being JSON or NS objects in my iOS app is ultimately what I care about as a client-side developer. And with this framing in mind, coming at it not from the standpoint of the server engineer publishing resources or the database engineer publishing performance characteristics, but instead from the perspective of the client engineer trying to get something built, we started building Graphql. Graphql is a query language that allows you to express what you need declaratively from the mobile app in the same code base, and then get back exactly that data, nothing more, nothing less. However the server wants to fulfill that, ideally as efficiently as possible. So we built this, and it seemed to work. A couple months later, GraphQL was powering a newly powered native newsfeed in the iOS app, and it hit the App Store about 3.5 years ago. So we've now been using GraphQL in production at Facebook for well over 3 years. And these days, we serve hundreds of billions of requests per day to our GraphQL servers, something along the lines of 300 billion requests per day. It continues to grow. So this is not a nascent technology. This is a thing that we are using at scale, under load, and it works great. And so we stick GraphQL here in this piece of the stack. And this has become the way that we build mobile applications at Facebook. We no longer build RESTful services, we build GraphQL services. And recently we also launched a library called Relay, which I'll talk a little bit about later today, that ties together React and GraphQL, which allows us to take what we originally built to power native mobile applications and bring it back to the web again. So what's GraphQL? Let's dig into this, see how it feels to use this. This is kind of the hello world of GraphQL queries. I just want to get my name. And the first thing you'll see is this looks kind of like JSON. We have these curly things that look a little bit like objects. We call them selection sets. And within that, we have things that kind of look a little bit like object keys, and we call these fields. So fields themselves can have selection sets, which allows us to describe nested requests. And if we send this as a string to a GraphQL server, it gets parsed, executed, and it returns a response that looks like this. And the thing that you'll probably notice first is that the response looks just like the query. They have the same structure. And this is a really important part of why GraphQL is intuitive and easy to learn from the perspective of a client developer. The GraphQL query describes the shape of the data that you will get back. So here the name is a field on the object returned by the me field of what? The top level of these queries represents the entire graph, all information available to you in a service. And since the graph has no middle, no start, no end, what we need to do is grab a spot to start. And this is one way to do that. And at Facebook, me gets me my Facebook user object. But this is not the only thing. In fact, there's even another way to do that. This is a more programmatic way to get my user object on Facebook, is I can look up by ID, for the same reason that you would want to look up by ID in any other environment. And what we have here is kind of a little bit new piece of syntax. ID is a field argument. And you can kind of think of these fields like functions. And functions return values that you can then ask for more fields on, but sometimes functions need arguments. And we can also request fields that have complex values. So here, profile picture, it's a complex value. It comes back with a struct that has a width and a height describing the size of the image, but also a resource URL to let you actually go load that thing. And again, I bet you can expect what data is going to come back from this query. It looks like that. In GraphQL, you always have to specify queries down to the scalar leaf values. And that leaves zero ambiguity of what's going to come back as a result. So I couldn't just say, me profile picture, done. It would say, what exactly do you want on profile picture? And here we've got a profile picture that's 50 by 50 pixels, but say I want a profile picture at a different size because I'm on a Retina phone or I'm in a different context or I need a different size. I can provide a field argument. Right here, this changes the behavior. So now I can say, actually, I want a profile picture of this size. And it changes the response accordingly. But what if I want two profile pictures? I want the small picture, and I want a big picture. So we can request profile picture 2 times. And here we've added another little piece of syntax that we call aliases. So aliases allow us to tell the server to request a particular field, but return it back in the resulting JSON with a different name. And that lets us query for the same thing multiple times and come back with different names. And then the resulting response here adheres to the actual names that we care about. But most importantly, GraphQL is designed not just to query the properties of one object, but smoothly follow connections between those objects. So I can query not just my name, but the name of all of my friends in a single request. And notice that this is the point where SQL would require you to write a join query. A REST API would expose URLs to follow and do follow-up round trips. And you can imagine if I wanted to get the names of 1,000 friends, that could be a lot of network requests. Or you end up with some parameter to do like field expansion. But we didn't have to do anything new. There was no new parameters. There was no new syntax to go deeper. We just asked for what we wanted. And of course, you can keep going deeply. So not only do I want my name and my friend's name, but I want to know what events are they going to and what are the name of those events. And this, again, is a very simple query that I can run, and I don't have to do anything new. And now I've not only gone from me out to my friends, but I've gone from those friends out to the events that they're going to attend. And this could be a pretty gnarly join query as we start to write it in SQL, or a pretty crazy field expansion within REST. And I want to trade off between the amount of information that I get back and the time it's going to take to load that, of course. So I can express some constraints via field arguments. And this is fairly typical for GraphQL queries to be able to say, I want the first one, I want it after this other one. And this is the basis for doing pagination in large lists. So that's GraphQL. That's how we speak GraphQL. And there's a handful of core principles that make GraphQL actually powerful. I'm going to go through and talk about some of those. And the first is the mental model. So I'm sure as you were just looking at those queries and responses, you're like, yup, makes sense. It's really easy to learn what's going on when you look at a query. And if you say, this is the data that I need to get back, it's pretty easy to learn what kind of query you need to write to get that data. This is really, really important in programming languages in general, and query languages in particular. But at the core of GraphQL is a type system, which you define, that expresses all of the capabilities of a server. At each level of a GraphQL query, a particular type applies, describing not only what fields are available, but what arguments you can supply to those fields, and what types are going to result from those fields. So this is static typing, static strong typing. So let's look at that in terms of a query. Here's one of the queries that we were looking at before. We're going to get my name, profile picture, and some information about that. We're going to get the name of one friend and the name of the next event that they're attending. So we're going to start with the me field, and on the top level, we often have a type called query that describes all of the fields that we can ask for, and me is one of those fields, and it's going to give us back user. Within user type, we have a bunch of stuff that we can ask for, name, profile picture, friends. It describes the arguments that we can ask for, and not only that, but the kinds of values we can provide. So it turns out that order by here is not the set of fields, but it's an enum. And this is important because we don't want to be able to sort by anything, right? Because that's going to go to the database, and the database is like, you're going to sort by something that's not indexed. That's going to be very, very slow. What this allows you to do as a server-side developer is only expose the capabilities that are actually going to be fast. So we don't expose the ability to, order by anything other than first name, last name, importance, because it turns out under the hood, that's actually what we've implemented to work quickly. Profile picture describes width, height, URL. It's integers and strings. And friends it returned a list of viewers. And notice we didn't have to add new syntax for dealing with lists. We're just going to ask for the same information about each item in that list. And again, we're in user, so we can ask for the name, and we can ask for events. Events is also going to return us a list of events. And then within that, we can ask for name. So we have a type system. We can follow the type system as we follow the query. Typically, most RESTful applications, at least that I've worked on, the app server owns the model data, and the client owns the views. And a client, it asks for a model, usually using some ID, some resource URL, and the server is going to respond with some data for that model. But it creates a coupling where any data change needed from the client, you're going to change a view, now you need subtly different data, it can require a similar change on the server. But that means that you have to keep both in sync. So now the server needs to be aware of the fact that the client needed separate information, usually by some version identifier or something like that. Keeping these two in sync, it can lead to some pretty serious code debt. If you've worked on a RESTful service that supports multiple clients, it's expanded over the course of a year or so, this can get pretty crazy. It's made even more challenging when you don't just have a client, but you have many clients, all of which require different information. And you end up doing things like having fields that say, you know, if iOS, then completely arbitrary different set of fields. When we use GraphQL, the server describes the complete set of possibilities that it could fulfill, all of the data. And the client asks for the subset of that it actually requires. And so we went to get data. The models and views are both owned by the client. There's no more tight coupling to the server. We ask for a particular shape of data, and that shape of data comes back, and I can have 100 different versions of a client out there, all with different needs, and the server doesn't need to know anything about them. At Facebook, this allows us to support dozens of different applications, each of which we support all of the historical versions of, which includes all the way back to that very first version of native newsfeed that we launched 3.5 years ago. It still works. People still use it, despite the fact that we've launched literally hundreds of new versions of that app since then. But the fact is that we can do this, and we haven't had to introduce any kind of concept like versioning. There's still a single version of the GraphQL server. The next powerful principle is composition. So GraphQL is designed with composition in mind. Every level of a query, it appears in a similar style. But in order to match how client developers are thinking about GraphQL, especially in accordance to the UI and how queries for data align with the UIs that use that data, we've added a feature to the language called fragments. So fragments, it's the main piece of decomposition in GraphQL that allows you to take regions of data that you care about, chop it into a different piece, which allows it to be repeated and added all over your query. And a really cool thing that you can do with this is tie it directly to your UI, ideally via some pretty tight cohesion. Best case scenario, you have a single file that describes both what the data what data is required, and then also the rendering function for that view. So in this case, I want to render my profile picture, and a fragment on a user type, I'm going to need the profile picture, the width, height, and URL of that profile picture, and then in my render function, I just grab that data, and it's available to me, and I can guarantee that there's no more data than I need and no less data than I need. But I can also compose these things, and this is a great simplifying factor. So now I can use profile pic down in my person row, in this case, and I have this ... notation for spreading in a fragment into a context that allows me to compose these things. So this is the same compositional technique that makes React have a simplifying force on your application development. The same pattern can be employed on the data that you need as well. So rather than having kind of one global point that describes all of the data that you need for your application, and then you have really nice composition for how the UI goes together, we can use that same composition in both contexts. This allows us to add and remove fields with confidence. If one remote piece of your application needs to expand it. if you're deprecating an old piece of your application, getting rid of it, and you're ever like, I wonder if we can stop sending that bit of information to the client. You can do that with confidence because you know only using that piece of information right here in this UI. So we recently launched this library called Relay. Relay helps you do exactly this, put your query right next to the render function. It builds on top of React and GraphQL to provide the super straightforward API that's just really, really nice to use. But of course, GraphQL was initially built for iOS and Android, and Relay came much later. So you certainly don't have to use Relay. You don't have to use React to use GraphQL. And in fact, some of the most interesting things that we're seeing in the GraphQL community as of late are tying it to separate systems. Another really powerful principle is that GraphQL is backed by code, not by storage. So when we were first putting GraphQL together over 3 years ago, on top of Newsfeed, we had all kinds of this custom ranking and storage engine that we certainly could not rebuild. We had all these other databases that we needed to query against, separate services. We certainly needed to utilize those. And we had cache layers all over the place. There's just no way that GraphQL is going to be a new database technology and replace all these things. That would just be a non-starter. In addition to that, we have just application code, right? Arbitrary business logic. This includes privacy rules. It includes when you write this thing, do these side effects so that when you create a story, it goes into the correct news feeds, right? Just lots of stuff that makes your application actually work. We certainly couldn't redo all of this either. We had to take advantage of this. So GraphQL is designed in a way that it leverages all of the stuff that you've already built because it is not a storage engine, but instead leverages arbitrary code, which means that it can run your existing code, which means that it's really easy to get started with GraphQL. And here's how that works. For every GraphQL type that we were talking about, it links to your code via functions, just functions. So let's take a little example here. We have the user type that we looked at before, name, profile picture, and friends. And in our code, it might look something like this. We have a function for each one of these fields. The function takes the value of the parent. So somewhere we requested something that would give us back a user, and now we're asking for the name of that user. So the first argument to the name function is the user object. And we can do all kinds of stuff. Literally anything you can do in a function you can do, right? So we can access just a property on that object. And in fact, that's the default. So if you omit the function, in most implementations, it'll just look for a property named that. You can call some other function, of course. And you can return asynchronous actions. So here, we're taking all our friend IDs, we're mapping over them, and we're promising to get back a user. So this is not only returning a promise, it's returning an array of promises. And this lets us, I'll hop through this. This in particular is really cool because since we're returning promises from these things, we're giving GraphQL the ability to coordinate the asynchronicity of fulfilling a query, which allows it to employ as much parallelism as possible in fulfilling these queries. It's just way less error-prone than like manually chaining together promises in JavaScript or whatever your asynchronous primitive is in whatever language you're using, because it allows you to actually decompose these things and spread them out and still do them in as parallel a fashion as possible. And it's at least just way more pleasant to code this way, because you write these asynchronous pieces in small, isolated parts, and then you compose them together in a way that no longer needs to concern itself with the actual asynchronicity. And GraphQL is not read-only. All of our examples so far have been about querying from GraphQL, but GraphQL also supports writes, it supports mutations. But our writes don't always work like a lot of other RESTful models or immutable client models. We're inspired by the Flux programming model, and GraphQL mutations are expressed as a collection of top-level actions exposed as fields that take arguments. So when we were building out our server, we had root fields. So earlier we had the me root field, and we also took a quick look at the user root field. And these were all implicit root fields of doing a query. But we can also define a mutation. And we use the mutation keyword to start a request of that kind. And now we have a different set of fields that we can get because we have a different root level object to query against. So for example, at Facebook, you can like a story. And liking a story is an action that you can take. And we, of course, have to provide some arguments. So what story is it that we are liking? And then once we've done that, we can fulfill a request. So the like story returns not just did it work or not, but it returns some information that may have changed. So it returns the story that we had liked, and now we can ask for stuff that is probable to have changed based on the action that we've just done, such as the number of likers and whether or not we actually like it. And another one that I probably should have added this example is a thing we call the like sentence, which is a little bit of sentence that says Bob, Joe, and 13 other people like this, which is all done translated on the server, and you always want to refetch that thing. And so where we would have previously exposed sort of a generic CRUD endpoint, we're now exposing explicit mutations to mirror exactly which CRUD operations we want to expose. But of course, we don't have to stop at CRUD. We can do all kinds of actions like accept a friend request or RSVP to this event that are actually kind of hard to model as CRUD operations. And we can do that in a way that feels very natural to client developers. So the type system is super critical to how GraphQL works. It allows us to take a look at that query and validate that, in fact, it is legal. But we wanted to take all this really good, powerful stuff and get it on the client. And in order to get it on the client, we needed some way to actually ask for this typing information. And good thing that we built a way to ask for structured information. So we expose the data about GraphQL via GraphQL. And we have a special top-level field that we call Dunder Schema. And Dunder Schema is an introspection API. So introspection, it gives us a tool for building other tools. And here's just kind of a scratching the surface of examples of what we can do with that. We can build documentation on the fly. So how many of you have ever used a REST API and been curious how something worked and went to go look at the documentation and read through the documentation only to find out that the documentation was actually out of date with the actual implementation? If your hand doesn't go up, then you're not programming against REST APIs. It's super hard. Like, how do you keep documentation and code in sync with one another? The only answer is that the documentation is actually part of the definition of the code, so that when somebody makes the change, it's just fairly obvious that they didn't update the line right above the function that says what the function does. So we expose this stuff, and one of the pieces of information that you define in your type system is description. And you describe everything. You describe types, you describe the fields on those types, you describe the arguments, you describe enums, and that description then powers the ability to build up documentation. We can also do code generation because we know the types within this. We can build the actual model objects that we would like to use as client developers, whether that's, in this case, just plain old NS objects. In Android, we generate plain old Java objects that have real accessors, and those accessors are correctly typed based on the ability to look at a query and look at a type system and know exactly what we're going to get back. And also note that we are asking for user, we're asking for a profile picture, and this is, I guess, yeah, it is clear to see what's going on here. Notice in user, there's no field that says friends. There's no field that says events. And despite the fact that those exist in my type system, I never queried for them in my application. So why bother adding weight to my application for some part of the API that I never used? So we can do all kinds of really interesting things. Also, after describing a query, we know exactly what the JSON coming back from the server is going to look like. So rather than running a generic JSON parser, getting back just dictionaries and arrays, and then fulfilling these model objects, we generate parsers for each query that you run so that as we walk through the result, we just instantly populate these model objects. Just all kinds of cool stuff you can do. And if you're using JavaScript, we're working on a project now that will generate flow types from a query so that you get some in IDE awareness of like, hey, you can't access that thing because you didn't add it to your query. And knowledge of the type system allows us to do IDE integration. So we can go beyond just syntax highlighting. We can do context-sensitive type heads, basically all the stuff that you want in a superpower IDE. And we can also do validation. So we can look at a thing and say, we don't know about superpower on type user, and this happens within the query body itself. And along with this, we can add commit hooks to make sure that nobody ever checks in code that contains a query that is actually invalid. So a lot of these features have showed up in a tool that we've built called Graphql, which is pretty punny of us. And I'll show you a demo of this in a minute. It's really cool. But one of the topics I want to jump into is how you get started. So say, at our company, we have a RESTful service, and it's OK, but this GraphQL thing, it sounds pretty cool. I want to try to test it out, but I know if I go to my backend engineer and say, hey, can you stop what you're doing and implement GraphQL, they're going to laugh at me. So how do you do this? How do you get started without upsetting your backend team or person? You REST Shim. Since GraphQL executes over arbitrary code, how about our arbitrary code is curl? And we'll start off just wrapping all of our existing REST endpoints. And of course, this is not the best final architecture. If you're building it from scratch, this is probably not what I would recommend building. But hey, this is a really great way to do this. And also, by the way, you might do this, and it might not be the best endpoint, but you may find some performance wins, because we're going to do parallelization for you. And if you've had to do multiple round trips to your REST service, we're moving that from between the client and the server to between the server and your existing REST endpoint, where network chattiness can just be really fast. So we're going to look at this in terms of this public tool called Swappy. Swappy is the Star Wars API. It's actually a really well-done REST API. It is public. You don't have to have authentication keys to use it, which makes it great for demos. It's very well documented, and getting info about the Star Wars universe is super nerdy, so I'm into it. It's pretty typical. Just REST-style resource URLs. They return JSON. And there's pretty good human-readable description of their type system, which is great. And as typical in most REST services, their connections to other kinds of resources are represented as URLs. So this is pretty much what we would expect for a RESTful service. Let's look at the GraphQL version of that. For the most part, everything's going to be the same. However, where there are links, we're going to keep that. And expand them in line. But here, can you notice what I looked at and shuddered? Anyone? Comma-separated strings. Ugh. I would much rather have that as an array. I don't quite understand why they decided to do comma-separated strings instead of an array. Yep, there it is. That's going to end up causing bugs in our UI. We're going to want to fix that. So here we go. We went in our code and said, we got a list of strings here, is actually what we want. Once we get the manufacturer, which in the REST model is modeled as a string, we're going to split it by string and trim it up a bit. Problem solved. All right. Demo time. I am brave enough to do a live demo, but not brave enough to do it from the live internet. And where's my cursor? There it is. OK. If you have a laptop and you want to follow around or you want to take note of this, you can actually find this. And here we will test the abilities of the internet. It is GraphQL Swappy, GraphQL-Swappy.parseapp.com. So where we sent this. And lo and behold, that works. I'm still going to use the local version, actually, because you'll be able to see the trace, and that is pretty fun. So we've got ourselves. First thing you'll notice is there's already been some requests fired. Request number 0 was loading up GraphQL. Can anyone guess what request number 1 was? We loaded the type system. As soon as you boot up Graphql, it immediately kicks back to whatever endpoint you configure, and it runs the full introspection query, and it loads up the UI with all the great features. Now I'm going to clear this out. Can you guys see this OK? It is a little bit small. Holler at me if you can't see. I'm going to delete our comments here. What we can do here is on the left side of the screen, we can type some queries. We've got a nice IDE environment. On the right side of the screen, when we run our queries, we get the results. This is kind of a nice demo environment. So let's get all of the films. And I want to know, for all those films, let's get the title. I can't spell, that's probably why. All right. And over here you can see that we went out to the Star Wars API and fetched /films in order to do this. But of course we didn't send back the entire payload of films, only exactly what we asked for. So here's the title of all those films. And let's say we also wanted the ID of those films. Oh, actually, I want the episode number. Episode ID. Okay, yeah, there we go. And of course gives it in chronological order. So there we go. We've got all of our films, and that was pretty fun, right? Well, let's do something more fun. Let's get, I don't know, all of the characters. And you notice I'm doing this characters connection, characters, all films. And that's because we have this thing called a connection model, and it lets us ask for other stuff. So say, actually what I care about is how many characters are there in each film. And I can get back, okay, you know, wow, Attack of the Clones had 40 characters versus the 18 in the original. And you notice that we still only went out to one API because all I had to do that was like get the length of the array that came back. But if I go back in here, I want not just the count of them, but I also want the characters, and I want the name, and I run that, then it's going to get me the name of all these characters, and you see like, oh, holy shit, okay, I went to films, I got all those URLs, and now it loaded them all up, and it loaded up basically all of them because I asked for all the films and all the characters. Let's clear that out. And maybe that's too many characters. Actually, what I want is just the first character. Oops, I put that in the wrong spot. Thank you, IDE, for telling me that I screwed up. I want to put it there. Okay, so you notice that we loaded films, and we loaded two people, people 1 and people 2. And that's because Luke shows up here a lot, and C-3PO shows up here a couple times. I believe that is listed by the first character that it appears in the episode. And so that's pretty cool. We did some caching, and so we only requested the stuff that we needed, even though the stuff appeared multiple times. Let's go deeper still. So we don't want to know just about the characters. We want to know where they came from. And you notice like this kind of reg squigglies keep coming up every once in a while. You can kind of hover over and figure out why. Homeworld on type planet, it must have a sub-selection. And that makes sense, because homeworld's going to return not an ID, it's going to return the actual object. And so I can get there, you know, Luke comes from Tatooine. But I can go even further, and I can get, yes, residents. I want to get their name. So now I'm getting all the films in Star Wars, how many characters are in each episode, the characters in those episodes, their names, what home world they come from, and also, by the way, the residents of those home worlds. And I did that in a single round trip here, but of course it took very many round trips to Swappy. There's all kinds of cool shit you can do in here. I didn't even touch docs, which allows you to surf through and look at all the stuff. So there's our documentation builder. But now back to our regularly scheduled program. Oh, don't do this animation again. Cool. All right, so that's GraphQL. What started as a tool for us to build a really awesome version of Native's newsfeed, it's become a critical part of how we build all software at Facebook, and with Relay now, it's a part of how we build for the web again. We decouple these things. We expose the capabilities via a type system, and we ask for requirements via the GraphQL language. That gives us the possibility to build some pretty awesome tools via introspection. And you know, when we first built GraphQL over 3 years ago, we had no idea that it was going to be critical to Facebook, let alone that we would ultimately open source this thing. We were just trying to build a good version of Newsfeed. But as it quickly expanded, more teams started to use it, we covered more cases, and we really never had a point in time to stop and look back and really assess what we had actually built in the beginning. So since the very beginning of this year, myself and 2 other colleagues dug into GraphQL and just reassessed everything. every assumption that we had made, every bit of the syntax, how the executor works, and just reevaluated, made things more consistent, made things nicer, and in the meantime wrote a specification for what GraphQL is and how it works. And earlier this summer, that's the first thing that we released. Alongside that, we also released a reference implementation built in JavaScript. You can get both of these things on our GitHub. If you go to GitHub/GraphQL, you'll find these along with many other of the projects that we've been building. And we chose this not because we like JavaScript. We do like JavaScript, but we can run this in Node.js servers, which is great for prototyping, and we can also use the exact same code base for our client-side tools. So in that demo that you saw before, Graphql is powered by GraphQL.js, but also the server that was powering GraphQL is also GraphQL.js. And at Facebook, we want to build a common set of tools. We want the tools that we build to be the same tools that our community is using. So Graphql itself is also open sourced, so you can use that. And we see GraphQL as this thing that can become a horizontal platform. It can tie together, regardless of what programming language you're using, what storage engines you're using, you can build on top of these things with one thin API that works on many different clients and many different servers. And the community response to this has been awesome. We've seen versions in Ruby, Java, Scala, Python, Go, Haskell. This is just scratching the surface. All of these were built by community members. None of them were built for us. They're all really interesting and excellent pieces of software. They work. The best part is when someone finishes the version of one of these things, the first thing they do is they stick Graphql on top of it, and they're just like, check it out, it works. And they just start going to town. Super cool. So you can learn more about GraphQL at our new website, graphql.org, which has links to the spec, the reference implementation, work by the community, and some documentation. And again, my name is Lee. Thanks so much for having me. Hopefully this has been interesting for you guys. And I look forward to seeing you back here at 2:20, where I'm going to talk about immutable data and why it's so freaking cool. All right, thank you.